The 1980s was supposed to be the golden age of excavators. More hydraulics, more power, more comfort. What operators actually got were machines that overheated, leaked non-stop, snapped pins, blew pumps, and spent more time broken than digging. These excavators didn't just disappoint. They angered crews. They destroyed job schedules. Some nearly ruined contractors. On paper, they looked revolutionary. On site, they were disasters. Today, we're exposing 10 of the most hated excavators from the 1980s. Machines operators still complain about decades later, and for very good reasons. Number 1. Komatsu PC200-1. The Komatsu PC200-1 occupies a strange place in excavator history. Today, Komatsu is synonymous with durability and hydraulic refinement, but the PC200-1 represents the company's early learning phase in mass-exported hydraulic excavators. Introduced at the dawn of the 1980s, this first-generation PC200 was intended to compete directly with Caterpillar, Hitachi, and other established brands. On paper, it looked capable. In real-world operation, however, it quickly developed a reputation that many operators never forgave. The most serious issue was the main hydraulic pump system. The PC200-1 relied on early variable displacement pump technology that proved sensitive to contamination and wear. Once internal tolerances degraded, the pump didn't fail gradually. Instead, operators experienced sudden and uneven loss of hydraulic power. A common complaint was that the machine could boom up but not swing properly, or travel strongly in one direction while barely moving in the other. These symptoms made the excavator unpredictable and, at times, unsafe on busy job sites. Another major problem was hydraulic heat management. Under sustained digging, especially in hard soils or trenching applications, hydraulic oil temperatures rose rapidly. Elevated temperatures accelerated seal failure, leading to leaks that further worsened pressure loss. In the early 1980s, hydraulic oil filtration standards were also less advanced, and the PC200-1 was particularly vulnerable to contaminated oil, a serious flaw for a machine expected to work in dusty, dirty environments. Operators also criticized the swing system, which felt underpowered compared to competitors. Swing slowdown under load reduced cycle efficiency and made truck loading slower. In an era when productivity gains were becoming critical to contractor profitability, this weakness stood out sharply. Maintenance compounded the frustration. Early Komatsu dealer networks outside Japan were still developing, and parts availability for major hydraulic components could be inconsistent depending on region. When a PC200-1 suffered a pump failure, repair costs often exceeded what owners felt the machine was worth only a few years later. This led many units to be parked, cannibalized, or sold cheaply, reinforcing the perception that the model was a financial liability. It's important to note that later PC200 generations corrected most of these flaws, but the PC200-1 itself left a lasting scar. Among operators who worked through its failures, the machine earned a reputation as unreliable, expensive to fix, and unforgiving of minor maintenance lapses, a reputation that firmly places it among the most disliked excavators of the 1980s. Number 2. Caterpillar 225. The Caterpillar 225 is often remembered not because it was catastrophically unreliable, but because it disappointed expectations, and in heavy equipment, disappointment can breed stronger hatred than outright failure. Entering the 1980s, Caterpillar was still riding the legendary reputation of earlier models like the 250. Operators expected improvement. What they got instead felt like stagnation. Mechanically, the CAT 2025 was robust. Engines ran for thousands of hours, frames were strong, and structural failures were rare. Yet the machine struggled where it mattered most to operators: hydraulic performance and ergonomics. The hydraulic system lacked finesse, controls felt heavy, response times were slow, and modulation was crude compared to Japanese competitors that were rapidly advancing hydraulic smoothness. Operators often described the machine as fighting back rather than working with them. The swing motor was a constant complaint. Under load, swing speed dropped noticeably, making truck loading inefficient. In trenching or foundation work, this translated directly into longer cycle times. While the machine could eventually do the work, it felt unnecessarily sluggish, a fatal flaw in an era when productivity metrics were becoming more data-driven. Cab comfort further eroded goodwill. The 2025's cab was hot, loud, and poorly insulated. Noise levels were high enough that long shifts caused fatigue and irritation. Ventilation was inadequate by 1980s standards, and visibility to the rear and right side was limited. Operators working 10-12-hour days judged machines harshly on comfort, and the CAT 2025 simply fell behind. What truly cemented the hate, however, was comparison. Side by side with Hitachi or Komatsu excavators of similar size, the CAT 225 felt old. Not broken, just outdated. Contractors noticed that operators preferred other machines, and many avoided assigning the 225 unless necessary. Ironically, Caterpillar's reputation worked against it. If a lesser-known brand had produced the 225, it might have been considered acceptable. But coming from CAT, it felt like a missed opportunity. That sense of betrayal, a machine that should have been better but wasn't, is why the Caterpillar 225 remains one of the most disliked excavators remembered from the early 1980s. Number 3. Hitachi UH083. Used throughout the 1980s, the Hitachi UH083 represents a classic case of a machine that impressed early, then slowly destroyed operator confidence over time. When new, the UH083 was praised for its smooth hydraulics, responsive controls, and competitive digging performance. However, as hours accumulated, a pattern of failures emerged that turned admiration into frustration. The primary issue was hydraulic system durability. The UH083 suffered from chronic oil leaks as hoses, seals, and fittings aged. Hose routing in particular was problematic, with lines passing close to sharp edges and heat sources. Over time, vibration and thermal cycling caused hoses to chafe and crack. Small leaks became large leaks, and large leaks led to pressure loss and overheating. Overheating was another major complaint. The cooling system struggled to dissipate heat during continuous heavy digging. Once hydraulic oil temperatures climbed, performance degraded rapidly. Controls became sluggish, swing torque weakened, and operators had to stop work to allow the machine to cool, a productivity killer. Maintenance demands escalated as machines aged. Owners found themselves replacing hoses frequently, tightening fittings daily, and cleaning oil-coated platforms and cabs. Oil mist buildup raised safety concerns, especially around hot engine components. While none of these issues were individually catastrophic, their constant recurrence wore down patience. The UH083 also suffered from long-term sealing issues in hydraulic cylinders. Minor seepage progressed into significant leaks, and rebuilding cylinders became a regular expense rather than an occasional repair. Why did operators hate it so much? Because it teased them. The machine could still dig well when it wasn't leaking, overheating, or being repaired. That inconsistency made it unreliable for scheduling. Contractors couldn't confidently assign the UH083 to critical work without backup. Ultimately, the UH083's reputation wasn't ruined by a single fatal flaw, but by a death of 1,000 leaks. In the unforgiving environment of 1980s construction, that was enough to earn lasting resentment. Number 4. Fiat Allis FR15. Early 1980s, the Fiat Allis FR15 is one of the clearest examples of an excavator that mechanics and operators actively disliked working on. While the machine was conceptually sound, its execution, especially in electrical and transmission systems, proved disastrous for its reputation. One of the FR15's most notorious problems was erratic travel behavior. Operators reported machines that would refuse to shift properly, lose one track drive without warning, or behave differently from one day to the next. These issues were often electrical in origin, but they mimicked serious mechanical failures, sending owners down costly diagnostic rabbit holes. The electrical system itself was poorly documented and awkwardly designed. Hidden fuses, non-standard wiring paths, and undocumented changes between production batches made troubleshooting extremely difficult. Even experienced mechanics struggled to isolate faults efficiently. In an era before advanced diagnostic tools, this complexity was unforgivable. Dealer support worsened the situation. Fiat Allis networks were inconsistent by region, and parts availability varied widely. A minor electrical component failure could sideline a machine for days or weeks. For contractors operating on thin margins, this unpredictability was infuriating. Operators disliked the FR15, not only because it broke, but because it broke mysteriously. Machines would fail, then operate normally hours later, eroding trust completely. No operator wants to take a machine into a trench knowing it might refuse to move out. By the mid-1980s, many FR15s were either parked, sold cheaply, or stripped for parts. Even today, the model is remembered less for its digging ability and more for the headaches it caused. Among 1980s excavators, the Fiat Allis FR15 stands as a textbook example of how poor system integration and weak support can turn a functional machine into one that operators truly hate. Number 5. Orenstein Koppel RH6. Early mid-1980s. The Orenstein Koppel RH6 is often remembered as a machine that was technically impressive but practically exhausting to own. Built during a period when O&K emphasized heavy-duty European engineering, the RH6 was designed to be durable, powerful, and precise. Unfortunately, for many operators and contractors, especially outside Europe, the RH6 became synonymous with downtime, complexity, and frustration. One of the RH6's biggest problems was its highly proprietary design. Unlike Japanese or American competitors that increasingly standardized hydraulic fittings, seals, and components, O&K used a large number of custom parts. Hydraulic valves, fittings, electrical connectors, and even basic service components often differed from common industry standards. When the machine was new and dealer-supported, this wasn't immediately obvious. Once the excavator accumulated hours and began needing regular repairs, the problem became unavoidable. Hydraulically, the RH6 was powerful, but its system was complex and unforgiving. Diagnosing pressure loss or valve issues required deep familiarity with O&K schematics, which were not widely available in English during the early 90s. Mechanics unfamiliar with European hydraulic logic often misdiagnosed issues, leading to unnecessary part replacements and extended downtime. Parts availability was the defining reason this model was hated. Outside of Germany and a few core European markets, replacement components often had to be imported. Lead times stretched into weeks. Contractors reported machines sitting idle over relatively small failures, failed sensors, valves, or seals, because replacements simply weren't available locally. Operators felt the consequences directly. Jobs were delayed, backup machines had to be rented, and confidence in the RH6 collapsed. Even though the excavator could dig hard and accurately when functioning, it became a liability in fleets that needed reliability above all else. The RH6 also suffered from electrical sensitivity. Moisture intrusion into connectors caused intermittent faults, leading to unpredictable shutdowns or disabled functions. These problems were especially common on machines used in wet or cold climates. Ultimately, the RH6 wasn't hated because it was weak or poorly built. It was hated because it was impractical. In the real world of 1980s construction, where fast repairs and readily available parts mattered more than elegant engineering, the O&K RH6 became a machine many owners regretted buying. Number 6. Mitsubishi MS122. Mid-1980s. The Mitsubishi MS122 is a classic example of an excavator that earned praise early in its life, only to lose nearly all goodwill as it aged. When first introduced, the MS122 was admired for its smooth hydraulic response and relatively refined cab compared to older designs. However, long-term durability issues slowly turned operator appreciation into resentment. The most severe problem with the MS122 was accelerated wear in its mechanical control system. Unlike later excavators that used pilot hydraulics, this model relied heavily on mechanical linkages between joysticks and control valves. Over time, pins, bushings, and linkage joints wore unevenly. The result was excessive play in the controls, making precise movements nearly impossible. Operators described the controls as floating, where joystick movement no longer corresponded cleanly to machine response. Fine grading, trench trimming, and pipework became frustrating and slow. No matter how skilled the operator, the machine simply would not respond consistently. Cab vibration worsened the situation. As linkages loosened and panels aged, the cab developed rattles that intensified during digging. Long shifts became mentally and physically exhausting. While these issues didn't stop the machine outright, they destroyed operator confidence and comfort. Maintenance could mitigate some problems, but only temporarily. Rebushing control linkages required significant labor and downtime, and many fleet owners deferred the work because the excavator was still technically functional. This decision accelerated the model's decline in reputation. Hydraulic components themselves were generally reliable, which made the situation more aggravating. Operators knew the machine could perform well, but the worn interface between human and machine prevented it from doing so. By the late 1980s, many MS122 excavators were still running, but deeply disliked. Operators avoided them when possible, and contractors noticed productivity drops when they were assigned. The MS122's legacy is not one of catastrophic failure, but of progressive disappointment. It stands as a reminder that operator interface durability is just as important as engine or hydraulic reliability. Number 7. Case 1088. Early 1980s. The Case 10088 entered the 1980s with high expectations. Case had a strong reputation for backhoes and construction equipment, and buyers assumed the company's hydraulic excavators would follow suit. Instead, the 10088 became one of the most commonly criticized Case excavators of the decade. The most frequent complaints centered on ergonomics and hydraulic responsiveness. The cab was cramped, with poorly positioned controls that forced operators into awkward postures. Visibility to the rear and right side was limited, increasing fatigue and reducing confidence during close quarters work. Hydraulically, the 10088 was functional but uninspiring. Cycle times were slow, especially compared to Japanese competitors. Swing acceleration lagged, and combined movements felt heavy rather than fluid. This translated directly into lower productivity. Operators often described the machine as working against you. Instead of flowing smoothly through digging cycles, it required constant correction and anticipation. Over long shifts, this increased mental strain significantly. Noise levels were another issue. Insulation was minimal, and engine and hydraulic noise dominated the cab. Heat buildup during summer work made conditions worse, particularly in regions without air-conditioned cabs. From a maintenance standpoint, the 10088 was not especially unreliable, but it wasn't easy to love. Repairs were straightforward, yet frequent minor adjustments were needed to keep performance acceptable. The machine demanded constant attention to remain tolerable. The biggest blow to the 1088's reputation was operator preference. Given a choice, operators consistently selected other machines. Contractors noticed morale drop when crews were assigned the 1088, and that perception spread quickly. The Case 1088 wasn't a failure in engineering terms, but in a competitive 1980s market, being merely adequate wasn't enough. The machine's lack of refinement earned it lasting dislike among those who had to operate it daily. Number 8. Kobelco SK120 Mark III. Late 1980s, the Kobelco SK120 Mark III is remembered as one of the earliest excavators to demonstrate the risks of early electronic integration. Kobelco was pushing innovation, but the technology wasn't fully mature, and operators paid the price. This model incorporated electronic monitoring and control elements intended to improve efficiency and protect components. In theory, it was a step forward. In practice, the electronics proved sensitive to moisture, vibration, and voltage fluctuations, conditions common on construction sites. One of the most hated traits was unexpected derating or shutdowns. Sensors detecting irregular signals would trigger protective responses, reducing hydraulic power or disabling functions entirely. These events often occurred after rain, washing, or overnight temperature changes. Diagnosing the problem was difficult. Faults weren't always visible, and troubleshooting required specialized tools that many dealers didn't yet have. Operators were left waiting while technicians experimented. The hydraulic system itself was capable, which made failures more aggravating. The machine would work perfectly one day and refuse to cooperate the next. This unpredictability destroyed trust. Electrical connectors lacked adequate sealing, leading to corrosion and intermittent contact. Once corrosion began, problems multiplied rapidly. By the end of the 1980s, many operators viewed the SK120 Mark III as a warning sign. Electronics could be useful, but only if robustly protected and well supported. The SK120 Mark III wasn't universally bad, but for many owners, it was a lesson learned the hard way, earning it a place among the most disliked excavators of its era. Number 9. Link-Belt LS3400. Used throughout the 1980s. The Link-Belt LS3400 is often described as a machine that was mechanically tough but deeply unpleasant to operate, a combination that earned it lasting resentment among operators in the 90s. Built during a transitional period when excavator design was rapidly evolving, the LS3400 retained many characteristics of older machines while competing against increasingly refined Japanese models. From a structural standpoint, the LS3400 was strong. Frames, booms, and sticks were durable, and catastrophic structural failures were uncommon. Engines generally ran reliably when maintained. However, reliability alone was no longer enough by the 1980s. Operator expectations had changed, and the LS3400 failed to keep up. The most commonly cited complaint was cab noise and vibration. Sound insulation was minimal, and engine noise, hydraulic whine, and structural vibration transferred directly into the cab. Operators routinely described the machine as exhausting to run for long shifts. Hearing protection was often used even inside the cab, which was not yet standard practice for excavator operators at the time. Vibration amplified fatigue. Continuous shaking through the seat and controls caused discomfort and reduced concentration. Over a full workday, this took a measurable toll on productivity and operator morale. Control refinement was another major issue. Compared to newer excavators, the LS3400's controls felt heavy and imprecise. Combined movements were difficult to manage smoothly, and fine grading required constant correction. While experienced operators could adapt, doing so required extra effort that made the machine unpopular. Carb comfort lagged behind competitors. Ventilation was weak, heat buildup was common, and visibility was limited by thick structural elements. In hot climates, working conditions inside the LS3400 became unbearable. The machine's reputation suffered further as newer models entered fleets. When operators experienced smoother, quieter excavators, returning to the LS3400 felt like a step backward. Contractors noticed that crews avoided the machine when possible. The LS3400 wasn't hated because it broke constantly. It was hated because it punished the operator every single day. In the long run, that proved just as damaging to its reputation as mechanical unreliability. Number 10. Samsung SE210-2. Late 1980s. The Samsung SE210-2 represents one of the most difficult periods in excavator development. The early entry of new manufacturers into a market dominated by experienced global brands. Introduced in the late 1980s, the SE210-2 was part of Samsung's push to establish itself in heavy construction equipment. While ambitious, the model earned a reputation that many early buyers regretted. The most damaging issue was inconsistent build quality. Unlike established manufacturers with tightly controlled production processes, early Samsung excavators showed noticeable variation between individual machines. Two SE210-2 units built close together could behave very differently in the field. Hydraulic system issues were common. Premature hose leaks, uneven pressure response, and variable valve behavior were frequently reported. While none of these problems were always catastrophic on their own, the accumulation of faults eroded confidence quickly. Welding quality also varied. Some machines developed cracks at stress points earlier than expected, especially in high-load applications. These failures weren't universal, but they occurred often enough to damage the model's reputation. Parts support was another major source of frustration. Outside Asia, Samsung's dealer network was limited in the late 90s. Replacement parts often required long lead times, and technical documentation was sometimes incomplete or poorly translated. Simple repairs could stretch into extended downtime. Operators also criticized cab refinement. Noise insulation and vibration control lagged behind competitors, reinforcing the perception that the machine felt unfinished. Perhaps the most damaging factor was unpredictability. Contractors rely on consistency across fleets, and the SE210-2 couldn't guarantee that. One unit might perform acceptably, while another became a constant problem. By the early 1990s, many SE210-2 machines were sold off cheaply or relegated to secondary roles. Samsung would later improve dramatically, but early adopters paid the price. The SE210-2 stands as a textbook example of how entering a mature market too early, with uneven execution, can permanently damage a model's reputation. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.